The first thing you need to do is to set up a data table that looks like this. So you will list what material you have. There will be 6 pieces that we're going to take data on. List the mass of each piece. And then this is going to sound weird, but I want you to list the final volume first and the starting volume second. And then we're going to subtract them to find the volume of each piece. We're going to do a video on density of stainless steel. So here I have 6 pieces of stainless steel. Piece number 1 is the smallest, and they work their way larger and larger until we get to piece number 6. So at this point, in order to find the density, we are going to need the mass of these pieces. So I have a balance set up here, and I need to make sure that it reads 0 before we get started, which it does. And I'm going to take piece number 1, bring it over, make sure it still reads 0, and take the mass of piece number 1. So I want you to write down that the mass of stainless steel number 1 has a mass of 3.03 grams in the mass of column of your data table. Okay, so we'll come back over, we'll repeat this for piece number 2. Make sure it reads 0. And this is the mass of piece number 2. Make sure that you write that down in your data table. Let's keep going. Piece number 3 this time. Here's your mass of piece number 3. Piece number 4. Looks like this. If I'm going too fast, feel free to pause the video at any time and record your data. Piece number 5. Record this data. And last but not least, let's record the data for piece number 6. Notice I made sure that the balance was at 0. And this is the mass of the last piece, piece number 6. And as we expected, the smaller pieces weighed less than the larger pieces. And you should see in your data table that the masses keep getting bigger and bigger. In order to find the density of material, you need to know its mass, which we've already found when we were taking masses on the balance. And now we need to know the volume of the piece. So the pieces of aluminum are irregularly shaped. They're tough to find a volume by using some math. So instead, we're going to use a lab technique that's called water displacement. I've already filled up this graduated cylinder with some water. And I don't know if we can get a good angle on this or not, but it looks like the bottom of the curve of the water, which is called a meniscus, is at about 7.1 milliliters. Let's take a look at this one. That looks like it's at 7. That one is a little bit above 7, 7.1, 7.1, and 7.1 again, once it focuses out there. So what I want you to do is I want you to record that the beginning volume, the starting volume for every one of these pieces is about 7.1 milliliters. So record that in your data table for each one of the pieces. Now, I'm going to take piece number 1 here and I'm going to put it in the water. Oops. I'm going to put it in the water and let the bubbles settle out here. And you'll notice that now the volume of water is higher than it used to be. That's because the aluminum piece down here has displaced the water. It's pushed it up. And the final volume of this appears to be about 7.4 because we always read from the bottom of the meniscus there. So you're going to record that as your final volume, 7.4 milliliters. So our final volume, if we subtract our beginning volume, 7.4 minus 7.1, that will give us the volume of the piece. So the volume of piece number 1 is 0.3 milliliters. Record that in your data table. All right, let's move on to piece number 2 here. Do the same thing. Drop it in there, let the bubbles go away. And I'm gonna let you read the volume of this piece and record it in your data table. Okay, let's take a look at piece number 3. Record the volume from the bottom of the curve, the bottom of the meniscus, in your data table. Oops, there's a bubble going up there. Okay, now you can record it. Let's try piece number 4. So here's 8 milliliters, and you can see where the bottom of the curve is. And let's try it on piece number 5. Let the bubbles go away and take a look at the volume of this piece number 5. If you need more time, feel free to pause the video. Piece number 6, put that one in there. Let the bubbles find their way out. Oops, let's shake that a little, get the bubble out. And take a final reading of the volume for piece number 6. Record that in your data table, and we are done taking data. There's something interesting about piece number 3 that I want you to see. Take a look at that. What's on top of the metal right there? How did it get there? And what effect do you think that has on your data? If I shake it, it goes away. Do you think that our data got better or worse?